Hello?
Hello. Hi, how are you doing?
Hey there. Pretty good. How about yourself?
I'm good, thank you. All right, so thank you for joining. There is some problem with audio apparently, but let's not worry about that. So we can start with the quick introduction. Speaking about me, I finished a computer science degree several years ago, and these days I work in machine learning and distributed services. Essentially, we have a machine learning model that we train. We look for ways to make it more optimal and accurate. And once we have good results, we put the model in production with the objective to have low latency and high throughput for the real-time requests that we get from users. So that's briefly what I'm working on. If you could chat a little bit about yourself, that would be great.
Sure. So I guess I'm a student studying computer science in Canada. I started programming a bit earlier in high school and continued that into university. I guess from there I ended up working a bit at my university and then other companies in the States. And I guess I was doing the interviewing.io stuff in preparation for interviews I had coming up.
Sounds good. So are you looking for internship at this point or full-time?
Yeah, internships.
Is it going to be your first internship or you already have some internship experience?
Yeah, I've interned before at some of the larger tech companies.
Okay, would you mind to chat a bit about what type of work you did there?
I guess maybe we could talk about it after with the, Don Anonymous thing, but for parts of it, I think in the first time there was some test automation material, second portion, making a performance framework as well as some dashboards for visualizing performance metrics. And then most recent, I guess I can't really mention it without like the product, but it was some web development.
Got it. Awesome. Thanks for the introduction. We can go ahead with the coding question.
Sure.
And
just switch this to Python.
Yeah, let me put the question here on the top. So let's say we have about 40 minutes to work on this question, so you can plan accordingly. And you can take your time to read the question and think about it, and then we can discuss possible all this.
Okay. So I'm given a list of float numbers. Am I just assuming that these are all floats when I'm getting that input?
Yep.
There's the 1, 12, 3. Okay.
Yep.
So the maximum value I can get. Am I allowed to assume that the values are always positive?
No, they might be negative.
Okay. Can I assume that the values also include 0?
Yes, you can assume that, yes.
Okay. Values also include 0. Okay. And then they can also include fractional values. Right, like so I can have numbers between 0 and 1, or 0 and -1. Okay.
Yeah. Very good question, by the way.
Okay, so right off the bat, one of the things I would think is that if I had all positive numbers, and they were all, not between 0 and 1, then my answer would easily be that I would want to just insert multiplication for all of the numbers. But because of the input, I don't have the guarantee that that'll be true. So right off the bat, as soon as I have some 0 somewhere, I know that I definitely don't want to multiply by, I don't want to use a multiplication there, and I can't use a division there just because that'll be completely invalid. Unless, say, the division followed after my 0 and I had to subtract or something like that. But even then, I think almost always using a plus is better whenever you have a 0, right?
Yep.
This also has to follow order of operations, right?
what do you mean by the order of operations?
So plus and minus don't, like the multiplication and division take precedence over plus and minus.
Well, it's actually described a little bit in the question, this topic. No, we
sorry.
follow the precedence.
Got it. They're of equal precedence order, meaning
Yeah.
Okay. In that case, I was thinking originally that I would need to add, say, these items to a stack and then try to, evaluate the bigger items on the stack according to some precedence, but instead I will probably be just taking it from left to right.
Exactly, yeah.
Because whatever number I have, just the next number is going to be affected. Okay, so right off the bat, I would think that there's some rules I can set based on the type of number it is in that case, just because I'm going from left to right. I'm pretty sure that for the times that my numbers are positive and greater than 1, I want to include multiplication. For the times that my number is 0, I want to make it an addition.
So those rules might get complicated, right? So you may have a lot of possibilities, and in the end of the day, it's going to be error prone and hard to implement. So let's think about a more general strategy. And
right.
I don't mind if we start with the brute force algorithm and then discuss how to optimize that.
Cool. So the brute force algorithm, it's something that I can think of pretty easily, where it'd be like, 4 to the n runtime, where I just make this kind of like a recursive function where each time I start from the 0th, say like the 0th element, and I pick 2, the final element, and I say, yep, I'm going to make a recursive call where one of them I try to add, one of them I try to subtract, one of them I try to multiply, and one of them I try to divide, with like, just some error check to make sure I'm not dividing by 0.
Exactly, yeah.
And for all of those, I'll just have to return the max that I get out of it. So that's one solution approach. I guess the naive solution is recurse with all 4 options. So what am I doing?
I don't mind if I don't mind if we do the brute force first. This will let me evaluate your coding skills, and then once we have that running, we can discuss the optimal algorithm.
Sure. Okay. Let's see. So what I said I want to do is I want to start from a pick of 0, pick until the end of my nums array, and then check for the max value. Okay. Oh man.
Okay.
By the way, one of the things I want to do.
If you feel that you need some hints, just let me know. Otherwise, I'll try not to interrupt too much. Okay.
Right. So one of the things I said I would do is, I would have my directed max value on, say, some plus nums pick. Oh, sorry, this isn't right, because what I'm doing with this is I'm making it that I actually have an extra operation before my final value. So, or I guess that before my first value, I guess that ends up depending on how I initialize it. So because I don't have an operator before the value, my initial summed is always going to be nums of 0. So way down here, I'd have directed max value of nums of 0, but then I have to do the edge case for that. So my pick is going to start from 1 instead of 0. Nums is none, 0, when of nums is less than 2. Turn nums to 2. So the one thing I guess that's kind of noteworthy is that I didn't include the multiplication example inside of the part where nums is not equal to 0. And the reason for that is because if my entire array, or sorry, if all of the value, if the greatest max value inside there ends up being a negative number, which I don't think should happen most of the time, I think that really only happens if you have 2 negative numbers in a row and they're way below 0, and then your third number is say 0.
Okay.
In that case, multiplying by 0 would give you the max value, right, of 0. So that's why that's not really included in that. So I guess reasoning through the recursive approach, I just have my quick error checks where I guess to clarify the input, should I be returning float of negative infinity or raising an error when I don't have a valid array? Like if I have none from my array?
you can use your own judgment for that case.
Okay.
I'm not
this case isn't required.
You can use your own judgment.
Right. So reasoning through, I guess the code that I wrote so far, what you have is my max bound starts off as negative infinity, which is as low as I can go. And then I say, okay, my starting sum is just going to be the first value, and then starting from the first index, I'm going to try and add it, subtract it, multiply it, and divide it. And then I made a mistake. This is supposed to be picks plus 1 for all of them. I'm just going to recurse. And as soon as I'm done making all of my picks, which means that pick is equal to len of nums, I check if the max, it's not max found. I check if my max found is less than the summed value I got. If it is, then I update my max found. And then I just return the thing in the end.
When you feel ready, let's run it on some test cases.
Sure. See, 1, 12, 3, the first example, right? So this one, local variable max found is referenced before assignment. Right, okay. It's because sorry, did you just disconnect?
No, I'm still here.
here. Okay, it gave me an error that you just disconnected, but I guess that was wrong. It's because I'm actually reassigning this value instead of it being like, say, a list that I can refer to. So just for convenience, what did I write before? Wait. I shouldn't get that error now. 39. Okay, so the simple case ran out all right, but I want to check those edge cases that I was thinking of earlier. So what happens if I have, oh, I didn't talk about what happens if I have 0 in the start. I guess it would just continue doing additions, but one of the things was I had super negative values, negative 50. Oh, crud, one of these have to be positive, though. Because if I just multiply them, they'll become positive afterwards. Let's do 2 and 0, which this one should give me 0. Yep, okay. Some other examples are...
Let me try out just one test case. I think I find interesting. 112 and negative 3. Let's try that one. 33.
Just giving me 33.
Right. So so we discussed already the runtime complexity, and I think this is valid. So now let's think about more optimal algorithm to do it. And you can again take a few minutes and think about it.
Sure.
And then we can chat.
Okay, so right off the bat, I would think that there should be some way for me to not have to do so many of these computations. In the sense that I should be able to just kind of cache them in some way. But I don't know if that's right, because what I'm thinking is that at each index, there's only a couple different values that it can be, right? So what I end up getting is that my directed max value at some pick plus 1, for some pick and some 1, so what am I saying? I'm thinking that I should have some cache where I have 2 values. Like instead of just having my pick, I would have, say, some pick and some summed that I should be able to look up. But I'm not sure what that exactly would give me back.
Okay, what other thoughts you have?
So the other point you go to is that, well, you can't really sort this. I don't see a way that some extra data structure may be useful, just because you will have to go through all of these elements left to right. There's no 2 pointers approach to this because, you know, there's no conditions you're looking for how to expand your pointers. So really, the thing that we're trying to optimize is the calculation.
Yeah, right. If exactly the computation, and maybe we can also think about it in terms of pruning possibilities. Maybe we can like pruning the branches. Can we do it that way?
Pruning the branches? You mean that some branches wouldn't be necessary some of the time?
Right. So in general, can we do somehow maybe to extract some values and continue with them, rather than just trying to evaluate all the possibilities?
Yeah, so that's what I was thinking with the cache idea. If you mean that we already know that some paths are invalid, I think that's what I was talking about before, but you said that would get really complicated to write out. So
no,
actually,
it's not like cache. I think this example that we have in the test cases of 1, 12, 3 and 1, 12, negative 3, they are illustrative of kind of possibilities that we might have with the algorithm.
Okay, so I guess let me think of what happens with 1, 12, 3. I have 1. You mean separately, right? Like for both of them, the process is much slower than it needs to be.
I think basically these two examples, they demonstrate what the optimal algorithm might be with this.
Okay.
Because,
so
yeah, so let's investigate them further.
Sure. So thinking of what I have for 1, 12, -3, I go ahead and I say that my first value is 1. I try to add 12, subtract 12, multiply by 12, and then divide by 12. And then once I do that, for each of the sums I have, which should be, 13, -11, 12, and then I have 1/12. I end up branching out from each of those to try and do addition, subtraction, and on with -3. How do I be able to prune that? So the actual tree ends up, being something like I have f on 1 on, it's not just f on 1, but let's just say I only have my sum that I'm going to include here. That I can just, can I necessarily just pick the max between those values? Let's think of that. Once I find a max between a bunch of values.
So by the way, it's f of -11, right?
Oh, yep.
Yep. Yeah. So I think direction of picking the max value is a good direction. So we can explore it further. It's not exactly.
You think that?
Yeah, I think it's a good direction. So we can definitely explore it further.
Right. So what I'm thinking is that for whenever I want to get the greatest list of floating, I want to get the greatest floating point number, then whenever you have the max between the options at n minus, say like some x minus 1 index, I figured that x is just going to equal the x minus 1 max that we found by one of the operations, which is plus, minus, or times. But this is only one example. I'm not sure if that always holds. But I'm thinking it should, because for whatever values we have, the different cases that we have to consider is that our maximum value is negative. At x minus 1, our maximum value is 0, and our maximum value is positive. So if our maximum value is negative, in that case, all we should have to do is try both the max positive and the max negative, because there might be another negative that comes up afterward.
Exactly. Yep, that's right. Yeah, I think you got it. Yeah, basically we just need to extract the max and mean values for each at each number, and then do the.
And then recurse on those.
We don't even have to recurse. We can do it iteratively. I mean, but yeah, I mean, we can go ahead with the implementation, and you can feel free to pick whether to do it recursively or iteratively. So it's up to you.
Okay. I guess because of how it's set up, I'll continue with the recursive approach. The downside to this ends up being like the larger stack size, but maybe I guess if we have time, we could change it. Right. So all of the values I had to check were let's see. That's not what I want to do. So what if I have numbers that are both the local max and the local min? I guess in that case, I would only want to, go down once, right? Yeah.
Okay.
So I'm thinking of how I could make this like not repetitive, where I kind of just compared all of them, but I have the same thing with the min. That's right.
Okay.
Right. And we're gonna recurse on
We can also do it. Maybe we could just place the values, the 8 candidates into some array or list, and then just extract the max and mean out of that list.
yeah, I guess that is the other option. You still end up calculating all of the, yeah. Right. Have plus, minus, times, and then I add divided if I can. Okay, there was definitely an error in this because now I'm getting negative 0.0 instead of the correct value. Where is the typo? So the code should pretty much, it's for a huge part the same. My summed plus pick val, summed minus pick val, summed times pick val. And here's an error where I said my local max is negative infinity. Oh.
Okay.
Yeah. Huh. It's just bothering me that it gives negative 0 instead of just 0. But was this example correct where I have 33? Should be should both be 39, right? Am I mixing this up?
Yeah, so feel free to add additional print statements or any other things you can do to debug it. So just don't feel constrained in any way.
Oh, then I would have to just read it. Okay, sure. I'm actually trying to think of how this gives 39 to begin with. 12 times 3? Oh, it's the 1 plus 12 times 3. No, right, because it's just left to right. In my head, I was evaluating this as with bed math, so I'm saying this is 37, not 39, but right. This is supposed to be 13 times 3, right? That's why that wouldn't make sense in my head. Okay. So when I go negative, my code here has my initial summed value as 1, and then I should just print off what my sums is. I think this is the most important part. Just kind of put out these spaces. So I have 13, 11, 12, 0. My max should, the first time, end up being 13. So what do I actually pick for local max? Yep, I pick 13 and negative 11, just like I should. And then the next time through, my max is 16 and negative 39.
Okay.
Huh. I'm not sure why there's another value that comes up after, because the very first time I pick my first local max and min, and then the second time I should be picking my second local max and min. And then after that point, my pick plus 1 should just make it that I'm done, and I've found all of my numbers. So I think the weirdest thing for me is that I'm getting a third array when instead my pick the first time is 1. And so that's where I'm getting the 13 and negative 1. Oh, because it's doing both the recursive calls. Okay, right. So in one case, it seems to be picking 13.
So yeah, we just need to have iteration over all numbers, generate 8 values, and then out of those 8 values, again, extract the max and min.
Wait, I'm sorry, I didn't catch that.
Yeah, so we generate 8 values for each number, and then out of those 8 values, extract max and min. We can place them in a some array or list, and then just basically call max and min on that list. And we can just continue.
I don't know what you mean by. I don't know what you meant by pick the 8 values.
So 8 values is actually 4 operators on the max, on the previous max, and 4 operators on the previous min. So that's why we have in total 8 values.
Oh, I see. So you're suggesting that we should actually keep track of what the previous maxes and mins were.
Yes. That's the strategy.
I see.
I mean, that's pretty much what. I mean, it's your logic is kind of very similar, right? So it's just minor changes to make it be like max and min for each number.
I'm not entirely sure I follow how that would end up working out. So you pick the max and mins from each number, but then what happened to the calculations as you've gone along? So if I have my max here of 13.
Let's consider this example of 1, 12, and -3. So we start with the pair max and min equals the first number, right? So it's going to be max equal 1 and min equal 1. And then on the next iteration of the loop, we compute 8 values. It's going to be so first 4 values will be between 1 and 12. And the other 4 values will be also between 1 and 12 because max and min are 1. Out of those 8 values, we will again extract max and min, which is going to be 13 and -11. And then we proceed with the similar strategy. But now we have 13 and -3. 13 is the max on the previous iteration, and -11 and -11 and -3. So again, we generate 8 values and continue with the next number.
Okay, let me, I guess, try and code out what I think you mean by this. So instead of having my local max and mins assigned here, this kind of changes what I understand as being what you meant, where you just start off and pass along your maxes every time. Oh man, do I have a typo? No. Oh, right, and then the other values are supposed to be that you have your local max plus your operations or your local min, right? That's yeah, I think these which methods these are supposed to all be. So this is what I kind of understood as you meaning by the 8 values, but I wasn't sure if I totally grokked that.
Okay. Are you clear now, or is still something not very clear?
If that's what you mean by the 8 by the thing is that you would just use your local max and min to calculate, then I guess I get that. And then I guess I wouldn't really need to use, would I still end up passing along summed? What am I doing with summed here? I'm saying that it's either local max or local min, right? At each recursive call.
Okay.
Is that really necessary to pass this again as info on summed? Not really. I guess I can make that my pick. I can sort of just have my local max, right, as instead of passing summed along. And I still got 33. Yeah, to be honest, I don't understand this new updated function that I wrote with the mins and maxes.
Okay, let's take a look at it and see what we can, how we can decompose that. So what do you think would be, first of all, what do you think would be the complexity of it?
So if I have the two recursive calls, I imagine normally you do getting 2 to the n, because that is still, you know, a solid, like you're still going to have that branching factor of 2.
Right.
In the worst case.
Reasonable. I think the problem though is that we decided to go with the recursive implementation, and the iterative implementation might have been a bit easier. So I think that with the recursive implementation, what we need to do to be able to kind of get it optimally is that we want to be able not to make 2 recursive calls, but instead just pass a pair from, basically just make 1 recursive call and pass the pair of max and min. So basically maybe as array of 2 numbers, or just those 2 values returned from the function.
Yeah, right. Okay. I forgot that this has been changed from what it used to be, and you don't really need the 2 recursive calls anymore, just because they are literally the exact same thing versus before they were different. Yeah,
exactly.
But that still doesn't change the correctness, right? Which I think the correctness was the problem with this one. Because I think it should still return 33. Yeah.
Great. Yeah. So once we have just 1 recursive call, what do you think would be the complexity now?
Now I get linear complexity. Exactly.
Yeah. Yeah. I think this takes care of the question. And yeah, so I think you did well today. So I like your skills for sure, and I'll be leaving positive feedback and recommending you for the next steps. And in terms of the next steps, you might get further interviews on the platform, and if there is availability. And if you do well, you will be given access to apply to the companies that hire through the platform. And something you can take a look at as a resource for continued preparation is, so we didn't have a chance to talk about the distributed system design today. And as a student, you not likely to get hard questions on those topics, but it's still possible. So what you could do is that you could just review some topics of system design, such as cap theorem. And I'll be making the notes here in the top of the screen.
Okay.
Cap theorem, and maybe also some blogs and videos on scalability. So I personally find Instagram engineering blog to be very insightful. So this is for the system design. For the and obviously there are plenty of other blogs like Twitter, Netflix. They should have very good articles and posts that you can follow. And for the algorithm questions, you can review DFS, sliding window, divide and conquer, dynamic programming, recursion, and greedy pattern. So in particular, this problem, like the optimal algorithms, is one example of a greedy, but with a twist. So we don't just want to extract the maximum. we want to keep track of both the maximum and the minimum, so it's kind of a variant of the greedy algorithm that you can use. And that's about it. I don't have further questions for you. Would you have any questions to me before we end?
Yeah, I'm actually curious. Are there people part of the interviewing.io team that kind of do these, or I'm guessing you're an engineer at a company, right?
Yes. I'm not. Yeah. So I mean, there are several people who interview on the platform. Some those who are hired by the interview.io, and some who are hired by the companies that hire through the platform. And there is also a category of people who just like to interview other candidates and just like to learn something and contribute back to the community. So there are several types of interviewers
on
the platform.
So when you say that I would pass for this one, is it mainly because of the thinking process? Because the actual optimal solution wasn't something I got, right? So.
Yeah, so the optimal solution is not trivial for this problem. So I don't expect people to solve it right away or even without hints. But I like the fact that you implemented the brute force with a good speed, with confidence, so that kind of shows your technical skills. And second question, you also kind of got to the right solution, but with some hints, so it's not a big deal.
Okay, got it. I guess because this isn't company specific, I didn't have any questions of that nature.
Yeah, makes sense.
Yeah, so I guess I'll just leave it at that. And you already mentioned that you do these as a way of giving back. That was going to be my other question of,
kind of.
What made you start this? Okay.
Yeah.
Cool. So thank you for your time.
Awesome. Yeah, you're welcome.
I'll definitely.
Have a good rest of the day.
Yeah, I like the advice for the Instagram engineering blog. Actually, I used to read the Uber ones occasionally, but I guess that's another source.
Right, definitely. And there are many blogs that I find useful, and this is one of them.
Right. Okay. Well, thanks, and
cool. Thank you.
Have a good day.
Yeah. Bye-bye.